All right, thank you, Katie, for sending me some questions. I got your number 3 on the last video. It looks like 9 is one that you need, so let's take a look at number 9. Number 9 is the integral from 2 to e plus 1 of 4 over x minus 1 dx. All right, so this is going to be a u sub. So u equals x minus 1 du equals dx. All right, so I've got the integral of 4 over u du. And if I plug in these endpoints into u, 2 goes in for x, so 2 minus 1 is 1. And e plus 1 minus 1 is just e. So now I don't even have to think about these endpoints anymore. I can continue with these guys here. All right, so 4 can go to the outside. And we're integrating from 1 to e of 1 over u du. And the integral of 1 over u du is the ln of the absolute value of u. Maybe that's what you forgot. So 4 times the ln of the absolute value of u evaluated from 1 to e. All right, so here we go. 4 times ln e minus ln 1. Now, maybe this is what tripped up some folks too. When we're talking about logs, properties of logs, this means you're dividing. So this can equal 4 times ln of e over 1, which is 4 ln e, and ln e is just 1. So the answer is 4. So maybe there was some algebra 2. The calculus probably wasn't so bad. It was probably the algebra 2. All right, number 12 was asked about as well. Let's see if I can get it all on this board here. We're on DEF CON 5, people. I've got one expo marker left, so looks like I might have to venture out in an essential item run. All right, we've got y equals the sine squared of x. And they're asking us to find the equation of the tangent line to the graph. So that tells me we got to find a derivative. So y equals sine squared x, and they want the derivative at x equals pi over 4. So we need to find y prime. So 2 sine x, it's a chain rule, times the derivative of sine is cosine. So there's our derivative. And let's find the derivative or the slope. This would be the slope of our tangent line anywhere. We want to know specifically at pi over 4, what is the slope? So sine of pi over 4, cosine of pi over 4. Alrighty, so that's 2 times square root 2 over 2 times square root 2 over 2. All right, so we've got 2 over 2, which is 1. So that's the slope of our tangent line. We have an x-coordinate of our tangent line. We need a y-coordinate of our tangent line. So let's find out, what does y equal when x equals 4? Well, we've got sine squared pi over 4, plugging it back into our original here. And the sine of pi over 4 is square root 2 over 2. Quantity squared will be 2 over 4, which is 1/2. All right, here we go. Y minus y1 is this guy equals m times x minus x1 was given to us. There you go. All right, and then number 13 was also asked for. So I'll do 13 on this video, and then I'll switch for number 20 and maybe a couple of others too that I thought would maybe be difficult. So 13, oh, I already did 13, just kidding. I did 13 in the previous video, just kidding. So let's skip over to 20. Number 20 is asking, oh, here we go. It's the integral from 0 to pi over 2 of sine 2x e to the sine squared x. Wow, that's quite a variable. or quite an equation. Here we go. Let's do I'm thinking a u sub on this one. What do you think? I think u sub. So let's let u equal sine squared x. So du equals 2 sine x cosine x. All right, this is how I started, and I got stuck because I looked and said, there's no cosine in this guy. But then when we go back to pre-calculus for just a second, that's where the cosine is going to come from. So I'm going to rewrite this, and I'll show you what I'll do with it. So it's the integral from 0 to pi over 2. Sine 2x can be written as 2 sine x cosine x. It's a double angle formula from way back in the day. So if you didn't get that, don't feel bad because I had to go look it up myself. All right, now we've got our du. So let's go ahead and replace this and turn this into u's. So e to the u du. And I'm also going to change my endpoints. So sine of 0 quantity squared, the sine at 0 is 0. So there's that. Pi over 2, the sine at pi over 2 is 1, quantity squared is 1. Love e to the u because the integral of e to the u is e to the u. So we are going to evaluate e to the u from 0 to 1. So that's e to the first minus e to the 0. And anything to the 0 power is 1. So e to the first minus 1, or just e minus 1. There you go.